All right, the optional lesson that goes along with the 10-3 notes is rationalizing a denominator. So this is pretty nasty. We don't ever want this for a denominator. We don't want radical minus radical. So if you remember way back in the day, not very long ago, we had a way to cancel out these pieces, okay? So if you remember the difference of two squares pattern, okay, this is going to be kind of weird. Okay, watch this here. Okay. If I take the square root of 7 minus 2 times the square root of 7 plus the square root of 2, what's going to happen is I'm actually going to have some things cancel. Okay, so over here on the side, I'll do a quick little poly box here. Okay, so here I've got square root of 7 and a negative square root of 2, excuse me. And then I have the square root of 7 and a positive square root of 2. Okay, so again, I got 7 minus 2, 7 plus 2. Okay, watch this. Square root of 7 times the square root of 7 is a regular 7. This would be a positive square root of 14. This would be a negative square root of 14. Oh, look at that. They cancel. And this would be a negative 2. So overall, I'd have a 7 minus a 2, which is a 5. Okay, so that's what happens. Okay, the opposite, the same two pieces, but one's a plus and one's a minus. Since this pattern happens, and since we have squares, since we have radicals, we'll get actual numbers that we'll subtract, and that's the whole goal. Okay, we want to make a rational denominator. We actually want a number on the bottom. Okay, so the quicker you can mental math that, okay, so this and this multiplied would just turn into a 7 minus a 2, so that's just going to turn into a 5. Okay. But this on top would be a 10 times u and a 10 times u. So we would have 10 square roots of 7 plus 10 square roots of 2. Okay, now from there you can simplify it even further. Okay, honestly what I should have done is I should have even written it that way. I should have written it like this. I should have written it as 10 times the square root of 7 plus the square root of 2 over 5, and that way 10 and 5 could cancel. So this actually would turn into a 2 over a 1. So this would actually turn into 2 times the square root of 7 plus the square root of 2. Okay, times u, that'd be 2 square roots of 7 plus 2 square roots of 2. Now it would be done. Okay, so again, this is pretty nasty. If you put this whole thing right here into the calculator, you should get the same decimal as this dude. Okay, because technically what we did is we took this times 1. Okay, anything divided by itself is 1. We just made the numbers look pretty. Honestly, it's no different than if we had 1 over 1.5. Okay, and we took the top times 2 and the bottom times 2 to make it 2 over 3. Okay, prettier fraction, not so pretty fraction. Not as pretty of a fraction, so we literally just got rid of the denominator in this case. Okay, we rationalized it and we straight up completely got rid of it. Okay. So I kind of ran out of space here. So what would you do on this one? Okay. I would take the bottom times the square root of 10 minus the square root of 5. Do the same thing. Square root of 10 minus square root of 5. And then you would just repeat the whole process. Okay. You would see what would cancel. I don't think anything's going to cancel because 10 minus 5 is 5. We'd have a negative 3 over that, so I don't think anything would cancel, but it's basically going to be the exact same process. All right, so we're not going to spend a ton of time on that. I just kind of wanted to show you that for extra notes. This would be connected to EE.7, so if you want to challenge yourself, give those a try a little bit, but those are optional. I might have a demo video up. I'm not sure if I'll do a demo on that one, but I will definitely have a demo video on EE6 and EE5. Okay, that's it. See you in class.